Hey folks, welcome to another set of Intro Chem video notes. In today's lesson, we're going to learn about atoms, isotopes, and ions. More specifically, by the end of this lesson, I hope you'll be able to define and illustrate the structure of an atom, isotope, and/or ion, determine the number of subatomic particles, atomic number, mass number, and charge, given the relevant data, and calculate the average atomic mass given isotopic abundance data. Let's get started. In the last lesson, we learned that matter is anything that takes up space and has mass. But just what is matter made of? This is a question we've been asking for centuries. In fact, around 440 BC, a Greek philosopher named Democritus is credited with being one of the first to ask this question and come up with an interesting answer. He asked himself how many times could he cut something in half until he could no longer. He concluded that there's likely to be some incredibly small particle that couldn't be divided anymore, and he called it atomos. Basically, he's the first to think of the idea of an atom. At the time, other philosophers like Aristotle completely wrote him off and pushed the idea that atoms didn't exist and that all matter was created from four elements: earth, water, air, and fire. Unfortunately, as awesome as it would be, though reality is far removed from the physics of Avatar: The Last Airbender, the people of the time agreed with Aristotle because his ideas made more sense based on what they could actually observe or experience in their lives. Based on that, technically, Aristotle's theory was just as correct as Democritus's, as one was backed by just as much as scientific data as the other. Fast forward about 2,500 years and we get to John Dalton, the first scientist to come up with a full-fledged theory of what atoms are. He defined atoms as being the smallest particle you can divide a substance into and still have the properties of that substance. His atomic theory stated that all atoms of an element are exactly identical, and all that matter is made up of atoms that cannot be divided into anything simpler. Both of those statements are partially true, but with more data, we did later find out that some atoms of the same element can be slightly different, and that there are particles smaller than an atom, like our subatomic particles, the proton, neutron, and electron. Atoms are extremely small. In fact, in a single penny, there's about 20,000 billion atoms of copper and zinc. In other words, there are 3 billion times more atoms in a single penny than there are humans on Earth. The basic structure of an atom includes a small, tightly packed nucleus in the center that's made up of protons and neutrons, and a larger, mostly empty space called the electron cloud, where the electrons exist. Let's talk about those subatomic particles a little closer. This is a great time to fill in that subatomic particles chart that you have to glue into your notebook. A proton has a positive charge of 1. I always remember that because protons are positive. Its actual mass is extremely small, about 1.7 times 10 to the negative 25 grams. That's a really small and hard to remember number, so we tend to speak in terms of relative mass with units of atomic mass units, or AMUs. The relative mass of a proton is 1 AMU. As we said on the last slide, protons exist in the nucleus along with the neutrons. Neutrons are basically the same thing as protons, but they do not have a charge. We call them neutral. So neutrons are neutral and have a charge of 0. They have the same relative mass as a proton. Electrons, which exist in the electron cloud and not in the nucleus, have a charge of -1. They're so small compared to protons and neutrons that we say their relative mass is 0 AMU. Knowing that information, we can come up with a few different ways to talk about atoms. The first and most important way is the atomic number. Every element that exists has a unique number of protons that go with that element. Every element of hydrogen always has exactly 1 proton. Every element of uranium always has exactly 92 protons. So we use the number of protons as the atomic number. The number of protons gives its elemental identity, so the atomic number is just equal to the number of protons. The mass number is basically just the relative mass of the whole atom. We just said that protons and neutrons have a relative mass of 1, while electrons have a relative mass of 0. That said, if we add up all of the protons and neutrons in an atom, we get the overall relative mass, or mass number. This number is usually close to the average atomic mass that's reported on the periodic table, which we'll learn about in a few minutes. The mass number can be different from atom to atom of the same element because they could have different numbers of neutrons. Electrons are the driving force behind chemical reactions and chemical bonding. An atom tends to lose, gain, or share electrons to bond with other atoms. Therefore, since the electrons are not nearly as fixed in an atom, we don't use those to name the atom. When naming an atom, you can use the symbol by placing the atomic number as a subscript and the mass number as a superscript just before the 1 to 2 letter element symbol, or you can represent it with its name followed by its mass number. As long as we know the name or element symbol, we don't really need to know the atomic number, because that can be easily found by looking up that element on the periodic table. Speaking of, here's a periodic table. You're going to need to get familiar with using it as it holds all sorts of information that will help you throughout this class. The general idea is that the periodic table lists and organizes the 118 elements that we know of so far that exist in our universe. Each element box contains an element symbol, the 1 to 2 letter abbreviation for the name, usually the name itself, the atomic number, which is usually at the top of the box, and the average atomic mass, which is usually at the bottom of the box. The elements are cleverly organized from left to right and down, like you'd read a book, by increasing atomic number. It starts with hydrogen, number 1, then helium, number 2, down to lithium, number 3, and so on and so forth. As we said before, atoms of the same element might have different numbers of neutrons and therefore different mass numbers. These are known as isotopes. An example would be the isotopes carbon-12 and carbon-13. Both have 6 protons because they're both atoms of carbon, but carbon-12 also has 6 neutrons, while carbon-13 has 7 neutrons. In nature, of all atoms of carbon, 98.89% of them are the carbon-12 isotope, and the other 1.11% are carbon-13. Those percents are known as the isotope's percent abundance. With each isotope's percent abundance and the mass numbers, we can determine the average atomic mass of an element, which again is the mass that's reported on the periodic table. To do this, you can multiply each isotope's percent by its mass number, add all of those answers together, and then divide by 100. Here's an example using the element we just talked about. You take 98.89 times 12, and you get this. Then multiply 1.11 by 13, which gets you this. Then you'd add those two answers together to get this, and lastly, divide that answer by 100, which gets you about 12.011, which is the average atomic mass reported on the periodic table. The last thing I want to talk to you about today is ions. If you've been listening this far into the notes and have the audio on, then listen real close now. Draw the best eyeball, because ion, right here in your notes. This will earn you some extra credit points on your notebook grade for listening to the video. Okay, so far we've only talked about atoms. Atoms have an overall neutral charge because they have equal amounts of protons and electrons, and all the positives and negatives cancel each other out. When talking about atoms, you can assume that the number of electrons is the same as the number of protons, which is the same as the atomic number. Anytime an atom loses or gains an electron, it's no longer an atom, it's called an ion. Ions have unequal amounts of protons and electrons, and therefore have an overall charge. If an atom loses an electron, it'll have more protons than electrons, giving it an overall positive charge, and we call that a cation. You can remember that because cations are positive and cats have paws. When an atom gains electrons, it has more electrons than protons, giving it an overall negative charge, and we call it an anion. Some people remember that by thinking that anion looks like the word onion, and onions are negative because they make you cry. Well, that's all for today, folks. I hope you listened closely, wrote everything down, and learned something. As always, if you have any questions, ask.